In this concept, we're going to talk about properties of radical expressions. Now, we're going to talk about the product property of radicals. For any real numbers a and b, and any integer n greater than 1, if n is even and a and b are both non-negative, then the nth root of ab, or a times b, is equal to the separation of, so the nth root of a times the nth root of b. Also, if n is odd, then the nth root of ab is also equal to the nth root of a times the nth root of b. Okay, so what this basically means is that you can separate what's in the radical as long as it's two things that are multiplied together, or more, two or more. Separate them into separate radicals. Okay, let's look at some examples. So simplify. The square root of 16 times 36. So again, according to what we just discussed, we can separate this to the square root of 16 times the square root of 36, which is exactly what was done here. So square root of 16 times square root of 36, which is square root of 16 is 4, and square root of 36 is 6, which gives us 24. Okay. Another example. So find the, well, plus or minus the square root of 64x to the fourth. So here again, we can use the product property of radicals to separate the 64 and the x to the fourth, right? So the square root of 64 times the square root of x to the fourth. So 64 is essentially 8 squared. So again, taking the square root of 8 squared, we get 8. And then x to the fourth is essentially x squared squared, right? So taking the square root of x squared squared gives us just 1x squared. So this is the final result, plus or minus 8x squared. Okay. Next example, square root of 36a squared b to the fourth. Again, this is more than two terms, but we can just decouple them just like we discussed. We can separate them just like we discussed. So we'll have the square root of 36, the square root of a squared, the square root of b to the fourth, all multiplied together. The square root of 36 is 6, the square root of a squared is a, the square root of b to the fourth is b squared. So this is my result. Okay. The cubic root of 64. So 64 is essentially 4 times 4, which is 16, times 4, which is 64. So the cubic root of 64 is essentially the cubic root of 4 cubed, right? Which is just 4. Okay? Next example. The square root of 4x squared y to the 8th. Again, separating them, we get square root of 4 times square root of x squared times square root of y to the 8th, which gives us 2x y to the fourth, right? So this is the final result. The square root of 1/2 times the square root of 5/2. So there's a couple of ways we can approach this. One way is to essentially multiply everything under the roots, which is the opposite of what we were discussing, right? So instead of separating them, we multiply, right? So then we get 2 times 2 inside the root is 4 inside the root, and then 1 times 5 inside the root is 5 inside the root. Okay? So these two multiplied together give us this whole thing, square root of 5/4, which then again we can distribute the root to the numerator and the denominator each separately. So then we'll get square root of 5 over square root of 4, but square root of 4 is 2, so then we get just square root of 5 over 2. Okay? Another way to do this is to separate the roots to begin with which gives us, so square root of 1/2 is the same as square root of 1 divided by square root of 2, and then square root of 5/2 is the same as square root of 5 divided by square root of 2. And then we can multiply these radicals, right? Each of these two radicals. So radical 1 times radical 5 is radical 5. So radical 2 times radical 2. Again, we can just say, this is equal to 2, right? Because 2 is equal to square root of 2 times square root of 2. Or we could say square root of 2 times square root of 2 is equal to square root of 4, which is equal to 2. Okay, same thing. So we still end up with square root of 5 over 2. Okay, same answer, two different approaches. Either of them may be useful at one point or another. Okay, so it's nice to know both. Next example. Square root of 27 x squared y squared. Okay, so we can break this to the square root of 27 times the square root of x squared times the square root of y squared. Now the square root of 27, so 27 can break up to 3 times 3, which is 9, times 3, which is 27. Okay? So this is the same as, or, we can rewrite this also as square root of 9 times 3, or square root of 9 times square root of 3, just like we have here, right? And then square root of 9 we can evaluate to 3. And then keep the square root of 3 as is. And then square root of x squared is just x, and square root of y squared is y. Okay? So we get 3xy square root of 3. Okay? And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so we need to evaluate the following radicals. Okay, simplify. So square root of 4 times 81 is the same as square root of 4 times the square root of 81, which is equal to 2 times 9, which is equal to 18. That was easy. Okay. 3 times the square root of 144 times m to the 4th times n to the 16th. So that is equal to 3 times the square root of 144 times the square root of, this is times, square root of m to the 4th times the square root of n to the 16th, which is equal to 3 times 12, so the square root of 144 is 12, times square root of m to the 4th is just m squared, times square root of n to the 16th is n to the 8th. Okay? Which is, so 3 times 12 is 36, times m squared, times n to the 8th. Okay? And this is my final answer. The fifth root of 1 over 32 times x to the 7th times y to the 6th. So this is equal to the fifth root of 1 over 32 times the fifth root of x to the 7th times the fifth root of y to the 6th. Okay? So here's the trick. So 1 over 32 is the same as 1 over 2 to the 5th power. Right? 2 to the 5th power is equal to 32. So the fifth root of 32 is 2, right? Because 2 to the 5th is 32. That's how this works. So the fifth root of 1 is just 1, and then the fifth root of 32 is 2, and then times, so the fifth root, again, so I want something that has a power of, or a factor of 5, a power of 5, or a factor of 5, or a multiple of 5, I should say, rather. So 5, 10, 15, 20, again, so, you know, so we can evaluate it with the fifth root. So x to the 7th is essentially the same as x to the 5th times x squared, right? And then y to the 6th is also the same as y to the 5th times y, right? Fifth root. So this is equal to 1/2 times, so the fifth root of x to the 5th is just x. Let's use the dot just so we don't confuse the multiplication sign with x. So this is the same as the fifth root of x to the 5th times the fifth root of x squared, right? So the fifth root of x to the 5th is just x, but then the fifth root of x squared, you know, is just the fifth root of x squared. I mean, it doesn't simplify any further than this. Times, again, the fifth root of y to the 5th is y, times the fifth root of y. Okay? Now there's a couple of ways to write this in shorter form. You can combine this and this, right? So x squared times y inside the fifth root, right? In which case you would have 1/2 x, this x times this y, times the fifth root of x squared y. Okay? Or I'll give you another trick. So whenever you have a root here, the value of this root can also be written as an exponent, a fraction exponent, whereas the value of the root, okay, the n of the root, would be written in the denominator of the exponent. What does that mean? So let's say I have x to the third root of x. This is equal to x to the 1/3 power. Okay, let's say I have x to the, you know, x squared to the fifth root, right, or to the fifth root of x squared. This is the same as x squared to the 1/5 power, which is x to the 2/5. Okay? So now you can see how we can apply this here. So we have 1/2 xy times x squared y. We can say all to the 1/5, right? Or we could have combined this, so this is x to the 2/5, and then times x to the 5/5, right? Because again, x to the 1 is the same as x to the 5/5, which would have been, you know, 1/2 x to the 7/5, and then y, so this is y to the 1/5, and then y to the 5/5, which is y to the 6/5. Okay? This is probably the most simplified form. Okay? We've touched on this trick fairly quickly now. It will come up soon in future concepts, but just keep it in mind. Okay? Next exercise. Square root of 2/3 times the square root of 7/3. So we've done something similar to this, right? We can just multiply whatever is inside the radicals. So 2 times 7 is 14 inside the radical, and then 3 times 3 is 9 inside the radical, which is the same as the square root of 14 over the square root of 9, which is the same as the square root of 14 over 3. Okay. Last exercise, we have square root of 18 y to the 4th z cubed. which is the same as the square root of 18 times the square root of y to the 4th times the square root of z cubed which is equal to, so the square root of 18 is the same as the square root of 9 times 2, which is the square root of 9 times the square root of 2, which is 3 square root of 2. Okay, so 3 square root of 2, and then times square root of y to the 4th is just y squared. And then again, z cubed is the same as, the square root of z cubed is the same as z cubed to the 1/2 power, which is the same as z to the 3/2 power. Okay, so y squared, z to the 3/2, and this is my final answer. Okay, hopefully this was clear. This is it for this concept. See you in the next video.